Hello, welcome to lesson 23 of my Erlang tutorial. In this lesson, I will be demonstrating how to do error handling in Erlang in sequential programming. For multiprocess, we will be discussing in the future. So error handling is quite complex topic, so it could be that I will split this video to two parts. And let's start. So error handling, errors happens everywhere in software. You can divide by zero, or you can have some invalid input from the user. You need to handle these errors in the correct manner, and the Erlang comes with some very nice mechanisms to handle errors. They are called exceptions, and in Erlang, handling error is called exception handling. There is expression for handling exceptions or for trapping them, and I will demonstrate it right now. So first of all, there are three ways you can handle errors, or you can trigger error. One is with error, and here we are specifying why the error happened. This is a built-in function which allows you to uh, uh, if let's say a trigger error, and this is to denote a crashing error. User didn't expected this, so this is something I will demonstrate. Another thing is throw, and we want to throw an error, and also we want to specify value what happened, and this is kind of error which this is the exception, and this exception is probably documented in your API, and user of your API, the client of your API may want to handle this error. So it's good to document all the errors or the exceptions which are triggered with this throw, so that user can then handle them. This could be something like name is too short, or some validation error or something like this. And then we have exit, which we can the built-in function exit. This one is used in multi-process environment, where when error happens, we want to terminate process in which this error has happened, and then also the signal will be broadcast to all processes which are linked to this process, so that we can indicate that something has happened in this process. I will be talking about the linking and the broadcasting of the signals in the future. Okay, so for now, in this tutorial, I will focus on throw and error to show you in which situations you can use it. So let's write some small example. I will start with divide error. And maybe I will also mention a little bit about defensive programming before I will start. So in Erlang, defensive programming is built in, which means we don't need to check all the input arguments for all the correct values to write the defensive in the defensive way. We should only describe the behavior of function for valid input arguments. So you can imagine that this will make your code much more concise, because you are describing only the code for the valid input arguments, and then the rest, let's say, is handled by exceptions. Also, it is very important to never return values when a function is called with invalid input arguments. In this case, we need to raise an exception. This is called let it crash principle. So we don't want to save the word with our code. If something is incorrect at the input, we shouldn't produce any output. We should just trigger exception. Okay, so this module will be very simple. It will be called divide, and it will export only one function, divide. And this function will be dividing two numbers. Very simple. Let's try it out in Erlang shell. Okay, I will divide 10 by 5 and I get result 2. My function works correctly. So the best example to demonstrate error handling is of course to divide some number by 0. We have the result here, exception error. An error occurred when evaluating an arithmetic expression, in function divide 2. So we get the module name. This is the stack trace. So currently we have only one level of invocation. We only invoke this function, which inside doesn't invoke any other function. So there is only one level in the stack trace, but this is basically the stack trace, which describes you what happened. If we would have more levels of invocation of the function, this would be also included in the stack trace. We always have information in which module the exception happened, which function caused the exception, what's the arity of this function, so how many arguments it takes. We get the information about the file of this module and the line. So let's see, line 5 in our file. So this is exactly this line. So as you can see, this is very nice way to describe what happened in your program. We have the error here because we try to divide a by 0. Of course, something which is hard to do. So for this, I will show you what we could do. We could introduce the guard and we can throw an error. So I will implement another function, a b, when b equals 0. So we want to have another clause for situation where user is passing 0. He wants to divide by 0. So in this case, let's raise the error. I'm using the error beef and by 0, divide by 0, and I will pass here maybe also the number which the a, we will pass here the a, and here I can and the clause and recompile. Divide 10 by 2, okay, works as expected, 10 by 0, and we have now our custom exception. This clause was executed of this function, and as you can see, we have the exception error, divide by 0, and here we are passing 10. In function divide, module divide with arity2. So we get this nice overview what happened. And this is the way how to use the error beef. So we want to handle something which user may not expect to handle. This is the way how to do it. And now I will go on to the next example, which will show how to use this throw. So maybe maybe I could also show you how I could catch this exception in this case. So I will write here another function, run divide, maybe something like calculate AB, and here we want to invoke divide A by B. Want to divide, and now I will compile. Of course, I need to export my function. Okay, here you see it's wrapped, but it doesn't do anything useful yet. So I'm going to trap this exception, which is thrown here in this error beef, with the try catch, to demonstrate how the try catch looks like. Maybe I will write here small. Maybe first I will show the anatomy of try catch. Try catch looks like this. We have the expression which starts with try, and here we have function or expression which we want to calculate, and then we type off, and here we have pattern matching. We may have first pattern with additional guard, and for this pattern with guard, we may, with optional guard, we may want to execute this expression if this is true. We may also want to have second pattern with some extra guard, for which we will execute these expressions. And then we have the catch, and inside the catch we want to specify all the exceptions which may happen here in this block in try. So we basically first try, do something, and this code may trigger exceptions, throw exceptions. And all errors which will be thrown here will be handled here, or the first error which will be thrown here will be handled here. So how it looks like, we have the pattern of some exception with extra guards also, and here we want to execute some expressions to handle this error. Another and we may have a couple of others, and then we have after block, and this will be executed to clean up after execution. So you can imagine that here you are opening the file and you want to do something with this file, and you want to ensure that the file will be closed. This could be file or the database connection or whatever. Therefore, no matter if the code execution was successful or not, after execution you want to clean up here in this block. And then there is end. So it works like this. This one is executed. This one is executed. If everything from here is executed, also this block will be executed. If somewhere here error happens, this will be, since this error will be trapped and it will be handled here. It will be cached here. So here you want to handle this error, and also this block will be executed to clean up after this execution. The after block is optional, so you could also not include it here. Let's see how it will look in practice with this divide example. I will write try, of course, try divide. I want to execute here off, and here I want to first handle correct situation. So if I will go inside the try, it means I can just return the result. So I may type something like AB to show what was calculated, normal, and the val to show what was the result of this calculation. Then, in case error happened, I want to, of course, catch it. So here we used, first we specify the beef. In this case, we are using error. So we want to start with error, and then I want to handle exactly this one by 0 and some value, which will be actually the value of a. And then I want to return it. I could do something like, I can repeat it, so divide by 0. And here a b. Divide by 0, error ab. I will return such tuple. And here, as you can see, I don't have after. Now let me recalculate. Okay, here I will just write underscore so that I don't get warning that this variable is not used. So what happens here? I'm trying to calculate this expression, so I'm calling divide a by b. In case everything goes correctly, I have some pattern matching here of the result of this function, and I can do different things with this. In this case, if everything goes fine, I just want to return the tuple which shows me what was calculated, that the result was not correct, and here the value of the calculation. In case I will be dividing by 0. There will be, of course, exception from here, and it will be cached here. So in this case, I want to return such tuple. I will catch it here, and I want to return such tuple. Let's see how it will play out. I'm calculating 10 by 2. And of course, the result is this one. Normal calculation, everything goes okay. Therefore, I have 10 and 2, normal, and the result, 5. Let's see what will happen if I will try to divide by 0. The result is tuple also, and I got divide by 0, error, and 10, 0. So this is exactly catching of this. So this is how we are handling errors. Let's also try to add after here. And in after, I will just type cleanup goes here. Of course, in our case, we don't need to clean up anything, but here you can imagine that I could close all the files which were opened here, or database connections, or clean up all the resources which should be cleaned up in case of error or successful execution happened. Let's see how it looks like with after block. Okay, you see I have invoked calculate, we got the cleanup block, and we got also exception handling. If I would also divide by 2, also calculation, cleanup block, and or the after block, and the result, in this case normal. So this is how it happens in Erlang. The error handling happens in Erlang. I could also use catch, which is another expression to demonstrate you how to catch. I will write and throw. I will write another example. I will write search module, which will be searching for me for elements in list, and it will also give me information in case I want to have unique values in the list. So if user will provide to me the list of values which is not unique, or he wants to search for something which happens twice or more times in the list, I want to send trigger error or throw exception, not unique element exception or something like this. Also, in case user wants to search for something which doesn't exist in my list, I also want to send empty result. I want to throw empty result set exception. Let me demonstrate how to do it. Search one. I will call it search one because I want to find only exactly one element. If there is more or less than one, then I want to throw errors or throw exceptions. So here I will have search one element list. I want to search for element in this list. And I will also write the comment search for element in the list if found, if not found, exception is thrown, something like not found error, or just not found. Let's call it just not found, and then element. If found more than one, exception is thrown, not unique. Otherwise returns element. So this is it. How to implement it? We have something like result. I will use lists module and the filter, and here I will write the fun x, and in this fun I of course want to compare x with element, and list. So this is my function without error handling yet. Let's see how it will work. Okay, search. First of all, I will define some list, L1, 1, 2, 3, 4, 5, 6, and I can search for example, 6 in list L1. Okay, I found the element 6. And now, of course, I want to do my error handling in case as specified in this comment. So now if and if the length of result equals 0, I want to throw an error. Throw not found element. So this here I just want to check if this list result list is empty. It means I haven't found anything, and I want to throw exception, which user may want to handle, or user or the client may want to handle. Next, if the result is greater than 1, I want to throw not unique. And in another case, I want to return the element which was found. It's a little bit artificial example, but it's more to demonstrate how to throw exceptions in Erlang rather than I didn't want to make it too complex so that it's clear. The part of throwing errors is clear rather than everything else. Okay, so this is it. This is how I will throw these errors, and this error will be propagated up from this function. Whenever this block was evaluated as true, this error will be thrown, and then the rest of the function won't be executed. It will just thrown to the function which invoked this function, and then if there is a block which traps this error, it will be trapped there or handled there. If not, it will be propagated higher. and it will be propagated higher and higher until it will be cached by the system. So, which means exception which is not handled by developer, Erlang developer, it will be handled by Erlang system. And it will, let's say, break the code, right? Like in this example, when I was showing with divide by 0, it will just break the function and show the struct trace on the standard output. Okay, let's see how my function works. Now I have, okay, I am able to find 6. Of course, everything is unique. Now I will define another list where there are 2 elements. This list is not unique. So you may think of this as primary key in database, and you want this to be unique because you want to find the user by ID, for example. And in case this is not unique, of course, you should get the error. Search one. I want to search something which is unique as a first example. Okay, great. It gave me exactly the element. And now I want to search for 2, which is not unique, so there will be error, exception thrown. Okay, you see I have the stack trace, exception throw, not unique. I'm searching for 2, which exists twice in this, so it's not unique. So I get the exception. Similar thing if I would search for example, 6, which doesn't exist in this list, I would get not found. So in this case, it's throw, not found 6. Let's try to handle this to demonstrate you a couple of other things. For this, I will define the search function, and here again, I will type something like this: search one element list of a value. In this case, I just want to return the value, or type something like OK value. In case there was an error, I want to do the pattern matching, in this case throw, because I was using here the throw. If something was thrown from this function and it has the following structure: not found element, then I want to, for example, return not found. If the function throws not unique, I want to return not unique. So this is how I'm handling. I could maybe do some IO format to display it on the screen or something like this, or here I could also send the email if error happens, or do whatever which can be done when error happens. Let's see how it will be handled. Okay, search is unused. I need to export it from my module. Search 6 L2, and I have not found, and also 2 L2 not unique. So this is how I'm handling the errors using throw. I could also use the catch to catch statement, and the catch statement will convert for me the exception into tuple. So let me show you how it works. I could write something like catch search 1 6 and 2. So you see that when I'm invoking this, I get the exception, which is handled by the system, in this case Erlang shell, and I got standard output. I can also write catch statement before my invoking my function, and then I will get the result. It will convert for me this exception to something which then I can use and and compare, for example, in if or case to see what was the result. So this is the catch. And also I could a little bit rework this example. Let's say I would have here more things which are happening. Then I could just type something like and this here, it will catch all exceptions, this pattern matching. So let's just type IO format incorrect input, as an example. And then if I would compile it, for example 6 L2, I get the incorrect input. So I have handled all these exceptions which are thrown here. So the same should be for example 2. I also, as you can see, both not found as well as not unique was handled here in this block. So this is the way how to handle all exceptions without specifying one after the other. You can also specify such block which will handle all exceptions and also all types, including error, throw, and exit. So this is it about the exceptions. This is quite a big topic. I will be also showing in the future. Now I will be also implementing error handling in every function which I will be implementing to show you how error handling could look in given examples. That's it for today. Thanks for listening and have fun programming Erlang.